How do batteries work? By Alina and Maeve. So, what is a battery? It's a container consisting of one or more cells in which chemical energy is converted into electricity and used as a source of power. There are three main components of a battery: two terminals made of different chemicals, typically metals, the anode and the cathode, and the electrolyte, which separates these terminals. The electrolyte is a chemical medium that allows the flow of electrical charge between the cathode and anode. When a device is connected to a battery, a light bulb, or an electric circuit, chemical reactions occur on the electrodes that create a flow of electrical energy to the device. The battery has two sides, zinc and copper. The zinc oxidizes, which means it loses electrons, which are in turn gained by the ions in water, in a process called reduction, producing hydrogen gas. The reaction occurs in the barrier of a solution between the copper and zinc. This oxidation-reduction cycle creates a flow of electrons between two substances. If you hook up a light bulb, for example, between the two, you'll get power.
Batteries are present everywhere in our lives, from the tiny ones present in our iPhones to those found in cars. The batteries in the iPhone are called lithium-ion batteries. This is a rechargeable type of battery in which lithium ions move from the negative electrode to the positive electrode when you use your iPhone. When you charge your device, the ions move back in the opposite direction, so from the positive electrode to the negative one. Lithium-ion batteries are found in most rechargeable objects, such as computers, digital cameras, vacuums, flashlights, etc. Even some cars use lithium-ion batteries, such as the Tesla. In the Tesla, these batteries can weigh more than 1,000 pounds and are rechargeable if you plug your car into a charging outlet. Electrical cars are able to move because batteries convert electrical energy drawn from the batteries to mechanical power, which in turn moves the vehicle. This is such a more eco-friendly option than driving gasoline cars because electrical cars do not emit the greenhouse gases caused by gasoline.
Here is a power equation. In physics, power is the rate of doing work or transferring heat, also known as the amount of energy transferred or converted per unit time. The SI unit of power is the watt, 1 joule per second. Here is the equation for electrical power. Electric power is the rate per unit time at which electrical energy is transferred by an electric circuit. So, what are currents and voltage? If you have ever traveled to another country and had to buy a power converter, you may have heard of current and voltage because they differ country to country. But an electric current is a flow of electric charge. In electric circuits, this charge is often carried by electrons moving through a wire. It can also be carried by ions in an electrolyte. Voltage is the pressure from electrical circuit's power source that pushes charged electrons, current, through a conducting loop, enabling them to do work such as illuminating a light. Now, here is a practice problem of calculating electrical power. Here on the board is a simple, though not all that functional, circuit, a 9-volt battery connected across a 10-ohm resistor. So, how do we calculate the power across the resistor? First, we have to find the current running through it. This can be done with Ohm's law. If you're not already familiar with Ohm's law, it states that electric current is proportional to voltage and inversely proportional to resistance. Now that we know that 900 milliamps are running through the resistor and 9 volts across it, what kind of power is being applied to the resistor then? A resistor transforms electric energy into heat. So this circuit transforms 8.1 joules of electric energy to heat every second. So, there we go. We successfully used the Ohm's law and the electricity equation to find our answer.
Thanks for watching!